Everybody, what's good? What's going on? Welcome to the Wednesday live stream. Really excited to be here. This is what we normally do every Wednesday at 6 p.m. Eastern Time. We pick a topic and go, pretty in depth into it. And today's is going to be one that I love talking about and is really beneficial to new folks who are trying to get into IT and cybersecurity. And it's also beneficial for those of us who have been in for a while because it's always good to get a refresher on this. And that is having a solid foundation and methodology that we use for troubleshooting different types of IT and tech issues. So we're not just going to be, going off in the dark and just, making stuff up and plugging stuff in, hoping it works, rebooting stuff, running around crazy. We're going to try and walk through a logical process that is iterative and builds off of the previous steps. And I have this all together in an infographic that I made for folks. I think I did it maybe last year, specifically for folks who are doing the Network Plus, but you don't need to worry because it's not specifically just for that. We can take that and apply it across the board to a whole bunch of different things. So, yeah, we'll hop over. I'll bring that up and we'll kind of jump into that. But if you have any questions or comments as we're going through this, please go ahead and drop those in the stream. This is really a lot more valuable once we have, a whole bunch of people interacting, asking questions. And you never know that the question that you might have and want to ask is something that somebody else is already thinking of, or it helps kind of jog their memory for some other types of things as well. So it's good to do that. We're all in this together. So yeah, I really enjoy it when we have kind of that back and forth. As well, if you do find the video interesting as you're watching through this, go ahead and hit the like button. It's always a good way to let me know that the content is valuable to you. So yeah, let me hop over and bring up my other screen. And we have this infographic here. And what we're going to do is we're going to step through all of these different areas and kind of talk about the specifics that are behind them. And then at the same time, we're going to overlay it over a specific issue and kind of what the specific steps are for that issue in this scenario when following through this process. So I guess the important thing to understand here is it really starts with understanding whatever the issue is. Whenever somebody, you're in your work environment, somebody comes up to you and is like, hey, X isn't working, right? And that's the first place that we need to start when it comes to all of this, right? So in that first step with identifying what the problem is, it's kind of like going through, the 5 W's: who, what, when, where, and why, right? So who is the incident affecting? What specifically is it affecting for them, right? So is it, their whole computer, a specific application, a specific service? You want to get as much finite details as you can. When did it start happening, right? Is this something that has been going on for a while? Did it just start today at a certain time? And also where is important as well, right? So if you're working in a big organization, and you have multiple locations and sites and things like that, it's important to understand if something is geographically only affecting certain people in certain locations, right? Because there might be certain services that are dependent on other types of infrastructure and things in one location and the other location isn't. So understanding those 4 things right off the bat is going to kind of help you scope where you're going to drive this process as we try to find out more information. Kind of one of the first things that I like to ask whenever somebody comes and complains about something is also understanding what's changed, right? So if somebody goes, hey, the internet stopped working at, 5 o'clock today, well, a good follow-up question to that is, okay, well, what has changed within the environment? Was there any type of maintenance going on during that time? Did anybody do any reboots of any types of devices? Did anybody make any configuration changes somewhere within the environment? That's always a good question to ask. Second follow-up question, which you'd be surprised how often the answer to this might be no, is did it ever work before? Right? Sometimes people will come and be like, hey, I'm not able to get to website X. And you're like, okay, when was the last time you went there? Oh, I've never gone there before. Okay. What makes you expect that you would be able to get there? It depends on kind of your access policies and stuff like that you have in your organization. But let's say it's a new server and a new application that's internal within your environment. Maybe the correct firewall rules and ACL rules haven't been implemented yet. And this person is just assuming that the access would be completely open and ready to go, right? So kind of a few important questions to lay on top of the who, what, when, and where. And kind of another thing that we like to look at is maybe it's cascading problems. Maybe there is other issues that are going on, and this person bringing up this one item is actually because of cascading effects from something else. So it's important to understand what dependencies that particular incident that you're looking at might also have as well within your environment. So identifying the problem is going to be the first step here. And then the next thing that we do, right, is after we've kind of identified that, we want to move on to establishing some type of theory. But before we get to actually establishing a theory, this is where we're going to have to actually do a bit of troubleshooting and a bit of research. We're going to take kind of those data points that were provided by whoever let you know about the incident. And ideally, you want to be able to get that information from as close to the source as well, because sometimes it can be like, a game of telephone where somebody says something and it's not necessarily exactly what it ended up being. So when you are gathering that information, if you can get it from the end user, even better if you can have them replicate or show you what it is that they're seeing, that can often cut down a lot of miscommunication or misunderstanding of what the actual issue is that they're having. So like I said, with that information, we're taking that and we're going to start doing a little bit of research, right? So this is going to be starting to look into different possibilities and doing this in a logical manner. Well, there's a few different steps to this that we would kind of go through here. And this is going to be where we're going to do our research. So maybe we're going to go and we're going to Google some of these symptoms, right? A thing that you always want to do, and people sleep on this for whatever reason, they don't take it as seriously as they should, or they get so caught up in the incident happening and stuff like that and forget that these exist here. But you want to go and check your logs, right? You want to check your logs on the applicable devices that are kind of in this string or infrastructure string of what's being affected, right? So you might want to go and check logs on your network devices, or you might want to check it on your DNS server. You might want to check the logs on the application server that the person is having a hard time connecting to. You also want to, or I should say, once you start to get that information from research, look at your internal documentation, maybe look at previous tickets that you've had in your environment if you've had similar issues in the past. You want to start trying to narrow down where you think this issue is coming from, well, looking at it through the perspective of, say, like the OSI model, right? So do you think that this could be a physical layer issue, right? So if it's something that's completely affecting an individual PC, but nobody else is affected and they don't have connectivity to the network, well, is their NIC plugged in, right? Is their port on the switch turned off, right? That's layer 1, layer 2, moving up to layer 3. Do they have a valid IP address, right? And you can kind of step through what these possible issues could be depending upon the scope of what it is that the person is complaining about. So if they're complaining about not being able to access anything, right, then that's probably more than likely something that's going to be at a lower level on the OSI layer than something that is up at layer 7 and specific to an individual application. So, uh, as I said, you're at this point, really the end goal of step two is starting to put together possible theories of what could be going on, with this incident. And that's going to lead to the third step, which is going to be testing the theory. Uh, kind of an interesting thing when you're kind of stacking what these possible theories might be is you might want to, look at Occam's razor. I mean, normally the simplest thing or the most straightforward thing or the obvious thing is probably what you're going to end up seeing the issue actually be. I mean, every once in a while we'll get on a goose chase of something that is just incredibly detailed and technical and ends up being some crazy software bug that absolutely makes no sense. But probably 99% of the issues that we run into are simple things that we've run into before that, with the right understanding of which information or logs to go look at, once we have those logs in hand, is very obvious what the issue is. So, like I said, in step three, we're going to take that and test the theory, right? Now, testing the theory can mean a few different things depending upon the environment that you have and whether or not you have a test lab, and also kind of dependent upon what's the word I want to use? How impactful the incident is, right? I mean, if we're talking about a system-wide issue within your environment that's, taking down the internet for everybody, you have a little bit more leeway in trying things out or testing out possibilities if everybody's suffering some type of catastrophic incident and, complete removal of service within your environment. If that's not the case, then you have to be a little bit more tactful in the way that you go about testing things. So that might be doing testing in a test environment or on a test machine or on an individual machine, or maybe on the one user's machine that's actually having the issue. And as I kind of mentioned with that, depending upon what your environment is and what the specific incident is, you might have to follow whatever your change control processes are in your organization, right? If it's something that is an incident, but this thing or this service never really worked before, it probably isn't a good thing to just go starting to make configuration changes and turning things on to get stuff to work if there wasn't already approval to do that, right? So you want to make sure that even in your troubleshooting, if you are making drastic changes or changes that aren't aligned with your configuration baselines, that you're following whatever your organization's change management process is. You don't want to go too far outside of that unless it's in the event where you have some type of catastrophic incident and you're trying to restore service to everything. Then you might have a bit more flexibility when it comes to that, and you're able to do the change management paperwork after the fact. Side note, running through these types of scenarios and having tabletop exercises to talk this through with your operations and infosec people is a very, very good thing to do. So that way, when you do have incidents that come up that might be more aligned with having to make some type of changes to restore service, everybody's on the same page. So we have a theory, right? And we're going to go and test it. And if the theory is correct, then we can move on to the next step, right? We can move on to step 5. After we evaluate the theory in step 4, if it works, we move on to step 5. If it doesn't work and we aren't able to resolve whatever the issue is, then we kind of need to go back to step 2, which is establishing a theory, dig in, do some more research, look at some more logs, come up with some more potential ideas of what the issue is, and come up with some ideas of how we can remedy that. What you don't want to do is be too scared to modify your theory as more data points are known. You don't want to get too locked into something and you're kind of just banging your head against the wall and not making any progress when there's, new data, new logs, you've gone and done other information. You don't want to be locked too much into something if it's not actually leading you down a path of progress. I'm going to take a sip of water because I feel like I've been talking for like 15 minutes. So if you have any questions or comments at the moment, drop those in, and we can talk about that if they make sense here, or we can hold them to the end. All right, so we have gone through step 4, and let's say that we have ended up finding a theory, ended up proving to be correct on our test machine or our individual user. If the issue was just affecting that one user and we were able to resolve it, then we kind of, don't have to go through any type of planning to implement a organizational wide change. But if that's not the case and it actually is something that's affecting multiple people, then what we need to do at this point is take the theory that we've proven and tested and then establish a plan to resolve the problem. So when we do that, we want to understand, does the plan and configuration that we're going to be doing have any other unintended consequences? So if we're going to go and make some routing changes somewhere in the core infrastructure to try to resolve this, is making those changes going to have any other type of service impacts? Those are things that you want to understand, because you don't want to correct an issue and end up causing another issue, right? You also want to have some type of rollback or fallback plans in the event that your implementation plan fails. So you go to implement whatever configuration changes on the device. It doesn't resolve the issue. It causes other types of issues. You want to have a method of procedure, or MOP, that outlines what it is that you're going to do to step back to at least get back to the point of the operations that you had before trying to implement your resolution, especially if we're talking about making things worse. And then the last part of that is we want to make sure that in our planning, we schedule the maintenance to implement this fix. And in doing that, it's important to bring in all of the right stakeholders, right? So it's not just a person that or team that's going to be fixing the issue. It could be other teams that have other types of applications, infrastructure, other tools that are dependent upon whatever it is that you're changing, right? And then it could also be external consultants, management, security. You could even be bringing in vendors, depending upon what the particular fix is, whether or not you actually have on-site support with your vendors. It could be, an issue with some type of hardware appliance that you as a organization pay for maintenance and management by a third party, and they're the ones who actually have to come and do the work. So when it comes to establishing the plan and scheduling that, you want to make sure that all of the necessary people are aware of the incident going on, what your plan is to resolve it, getting them all on the same page, and go ahead and scheduling that to do that. So once we've done that and we have everybody on board, we have a schedule, we've planned it, we have, all of our stuff lined up, then we go to implement the solution, right? And so we're going to have all the folks that are necessary to be there to do the configuration change or hardware swap out or whatever it is, be there to implement it. As I mentioned, that might be bringing in a third-party vendor or something like that. Another important thing is you want to make sure that do during a time of minimal impact, right? So whenever we schedule this, we want to make sure that we aren't going to be doing it in the middle of the day, unless we're in a situation where we have widespread service disruption within the organization, right? At that point, you're going to be doing whatever you can to get things spun back up and working. But if it's something that, just requires a reboot of a device or some type of configuration change that might take services down, you're unsure of what the impact will be, but it's not necessary to do it right now, you're going to want to schedule that after hours so that you have the minimal impact and you don't cause any other major issues. Then once you actually go ahead and implement that solution, we're going to go to step 7, which is verifying the results. And this is really important because you want to verify that the incident itself has been resolved, but you also want to verify that you don't have any other cascading issues from the change that you made. and you want to make sure that everything else in your environment is working properly. So kind of a good best practice is to have like a quick little service checklist whenever you have any type of scheduled maintenance to make sure that the expected services within your environment are still functioning, right? So maybe you're going to reboot some devices. And even though it isn't directly tied to it, you're going to want to make sure that, internet access still works, DNS still works, your email still works, other types of critical services to your organization. When we mentioned before about locations and different sites and stuff like that, it's equally important at that point, if it's something that was affecting everybody at different sites and locations, to have folks at those different locations test out the issue as well to make sure that it has been resolved. Let's see. One other thing that we want to make sure that we do whenever we're solving these types of incidents is if it's something that we identify as having the potential to occur again, that we aren't just doing a stopgap measure, right? We want to make sure that we're implementing some type of preventative mechanism so that in the future we don't run into any other incidents that end up kind of continuing to happen, which at that point, they're no longer incidents, they're a reoccurring problem. So that's kind of a good goal to have. Sometimes that might not necessarily be the case, that you'd be able to do that, because sometimes it might require additional hardware or additional software. Maybe you need to have some type of scripting done or automation to be able to monitor and change configurations on the fly when certain events happen. But understanding that that should also be a goal for your incident resolution. It's not just, coming back or bringing back the services right now. It's also making sure that you don't have the same reoccurring incident happening over and over and over again. And that's going to lead us to step number 8, which is so important and doesn't necessarily always happen all the time. And that is going to be document the findings, the actions, and the outcomes. And the reason why this is so important is because it's the key to making sure that we're able to resolve future problems and maybe resolve them in a much more expedient manner, right? We've gone through this whole troubleshooting process, and depending upon, what the incident was, how long it took, coordination with all these different people, scheduling, planning, implementation, testing, all that type of stuff, that is an awful lot of work. And you don't want to do all that work and just completely lose the knowledge gained from going through that process. So that's why documenting some of the specifics about what happened, why it happened, symptoms, different types of things that you tested, what worked, what didn't work, the end configuration solution, those are all important things to document. And whether or not you keep those in your ticketing system or in some type of knowledge database or a wiki or something like that, hopefully something that you can search on via keywords and stuff like that, will add a lot of, how do I want to put this? It will codify a lot of intrinsic knowledge that folks in the future might not necessarily have, because they might have not been there doing the troubleshooting with you. And so if you're able to, like I said, take that knowledge and document it and make it something that's searchable and kind of help make that path repeatable, cut down on time, minimize the impact for future things, it can be quite helpful. And then we kind of mentioned before, incidents that continue to happen over and over and over again. Those aren't incidents, those are actually become underlying problems. And having the data points to be able to point to that, especially to management when it comes to having to spend money on fixing things, is really, really important. And so having that documentation to be like, okay, well, we've had these servers drop out of being able to provide service 10 times in the past 2 years because they have hit these CPU thresholds. We need to expand and get more resources. Having all of that documented, it's a lot easier to make a business case to spend the money to improve your infrastructure and services in your environment. So that's kind of the specifics of each step. Let's go ahead and take a look at an actual scenario that's here on this diagram and kind of walk through the scenario and how the specifics of that incident would overlay over the process that we just talked about. And again, I'm going to take a sip of water because my throat's getting dry here. Okay, so let us bring this here so I can read that a little bit. Okay, so in our scenario here, we're going to be talking about the internet and the organization is broken. Or is it, right? A user says that. What does that really mean? So in trying to identify the problem, we hear that multiple hosts within the environment can't communicate outside of their subnet. Okay. So the interesting thing with that is they can't communicate outside of their subnet, but it doesn't say that they can't communicate within their subnet. Now, being a network engineer and having troubleshot a whole bunch of issues like that, if you're familiar with that, then the answer should pop right in your head right away as to what that probably is going to be. But if you haven't, and you're not a network engineer and you haven't done a whole bunch of network troubleshooting, then that's going to be, a little bit nebulous, and we're going to have step through this process and kind of pull out different types of information to come up with, a theory and test it out and stuff like that. So the theory on this is going to be, since we can't talk outside the subnet, we can talk within the subnet. We think that a config change to the DHCP controlled gateway IP address broke the routing on the network. So we're saying that somewhere in the DHCP configuration, the IP address that was handed out as the gateway IP address for the subnet somehow got jacked up. Somebody made a bad configuration change somewhere. Now these devices got IP addresses for a gateway that isn't actually a real gateway. So they're trying to send traffic off of their subnet to an IP address that doesn't exist, or is an IP address that exists on a different device that isn't able to actually route off the subnet. Now, there's multiple ways that we could go about actually digging into data to end up seeing that this is actually the case. We could look at DHCP logs on your DHCP server. We could do some troubleshooting on the device itself to see what the gateway is. IPconfig /all, bring it up, see what the gateway is. Whoever is working as your network administrator should be familiar with what the gateway IP addresses are, and it would see, okay, that's an IP address that really isn't on the gateway. There's other types of logging that we'd be able to look at, possibly on your network devices. We could even do Wireshark and take a look to see, where the devices is trying to send outbound data based off of the MAC address, and we could look to see what the MAC address is and corresponds to an IP address. A whole bunch of different ways that we could go about troubleshooting that on individual devices and looking at logs. We also could do some Google searches on this. If we were to Google hosts can't communicate outside of their subnet, right? I'm pretty sure that there is a whole bunch of posts on Cisco.com of somebody asking about similar situations like that. So again, step 2, we're establishing a theory. We're doing troubleshooting on devices. We're looking at logs. We're doing research online. We're looking at any other documentation that might be necessary. And like I mentioned, if we've documented issues before in the past, and maybe this is something that we go back and we look at our wiki or our previous tickets, if that's necessary. Moving on to step 3 with testing the theory. So the theory is that the IP address being handed out for the gateway from the DHCP servers got changed and is wrong. So what we're going to do is we're going to manually modify the IP gateway on one host to the correct IP address and move on to step 4 to see if that host can then connect to the internet and other subnets within the environment. Okay. So at that point, we're going to say, did it work? Did it not work? Right. So if it didn't work, then we're going to have to go back to step 2 and come up with some new theories. But in this case, it is what the issue was. I'm going to say, yes, that did work. We're going to move down to step 5 for plan of action. So we're going to come up with, the plan to fix this. It really shouldn't be that big of a deal. We should be able to implement the change. The thing is, it might require some type of IP config renew and release. And depends on, how many, is it just the particular subnet that these hosts are in? If it is, this might be something, since it's not necessarily wide across the entire environment, then we just go ahead and make the change. But we do want to make sure that we come up with a plan, coordinate with the right people, and go from there. Step 6, as we talked about before, is implementing the solution. So we're going to implement that IP gateway change on the hosts and update the DHCP configuration. Again, there's a few different ways that we might do this. Depending on how big the environment is, we might actually just go and manually change the gateway on the hosts and then go make the change in DHCP. We might make the change in DHCP and wait for the timeout to happen and for it to, re-up and try to renew its lease, depending upon how long your lease times are in the environment. And, is this happening over the weekend when nobody's there? There's a whole bunch of other scenarios that can kind of go into that to determine, your actual real path for implementation for whatever fixing the incident is. And that's where kind of in step 5 before you kind of want to get together and talk about those things. So step 7 is verifying the results. So we're going to make sure that all of the hosts in that subnet can now access the internet. They can access other subnets. Everything works as expected. And there wasn't any other weird types of losses of service that happened because of our configuration change. In this case, there shouldn't have been, so that's cool. Then step 8, we're going to go ahead and update our trouble ticket. Hopefully you have trouble tickets, right, for an incident like this, and update any type of documentation, and kind of go from there. And yay, everybody's happy again. They can all go surf whatever it is that they were going to surf. Maybe the CyberInsight YouTube channel. Who knows? So yeah, that is kind of how we would go about troubleshooting a very particular issue using this methodology. Again, you can really use this anywhere for any type of tech or IT or cyber issue, as far as trying to identify problems, establishing theories, testing that out, having a plan, going ahead, implementing it, verifying it works, and hopefully taking some notes so that when you run into it again, you have an idea. So let's go over to the comments. If anybody has any comments or questions, queries, any of that good stuff, throw them out here now while we're here. Got one comment coming in. Currently studying for the Network Plus. So thanks for this. Awesome. Yeah, good luck on your Network Plus. Do you know when you're going to take it? That's going to be... I'm trying to think if they're changing it anytime soon. I don't think so. Maybe next year. Well, if nobody has any other questions or comments on this, I hope that this is useful to you. I put a link in the description for where you can get this diagram if you want to use it. I'm going to be completely honest with you. From the perspective of being a person who's a bit seasoned as far as working in an IT and stuff like that, it's not bad to refresh yourself on certain aspects of this, because sometimes you can get so caught up in the ops tempo or the stress of trying to resolve something. You might forget about certain types of logging that you have. And so having a clear mind and thinking about things logically, a little bit of critical thinking, a little bit of logic, we all have a little bit of both of those. But, when you're under stress, depending upon, what the issue is, sometimes we forget to look in some very, very easy or common places to end up finding information that once brought to light makes the issue seem a lot simpler than if we don't have that information. So it's definitely something that I try to teach to new folks that are getting in, but at the same time, it's always good as a refresher to kind of remind yourself uh, to follow a process like this. Even, as I mentioned, being more senior, being in an organization, stuff like that. Documentation is always important. Communication is always important. Bringing the right people together, doing testing, not being a cowboy and just making changes ridiculously. So it's really important for all of us, not only just new folks who are learning how to troubleshoot tech issues. Another comment coming in, very useful. Thank you so much. Appreciate it. I'm glad it was useful to you. Hope you're able to use it in the future somewhere. Let's see, anything else coming in before we wrap up? If not, yeah, hope everybody has a great rest of the week. As you've noticed, I've kind of been doing videos every single day for this mini series that I put together for best practices for designing secure networks. So yeah, if you're interested in any of those, I think I'm doing them pretty much 5 o'clock Eastern every day, both here on YouTube and on Twitch. They've been getting pretty good response so far. I'm kind of taking some baselines and best practices and kind of breaking them down in a way where it's digestible, especially for new folks who are just kind of getting into engineering and don't necessarily fully understand what are kind of some of the basic things that you want to do when building out an environment so that it's done in a operationally secure manner. So yeah, so we will wrap this up. As always, smash that like button. I appreciate that. If this is your first time on the channel, thanks. Also hit that subscribe button. That's always great to see as well. So yeah, hope everybody else has a great rest of their evening, and we will chat soon. All right, bye.